Assalamualaikum. My name is Muhammad Naim Iskandar bin Rahimi. Metric number B0821101114. Today I want to present of my part is oscillator 1. The first oscillator of synthesizer or other electronic musical instrument is generally referred to as oscillator 1. A circuit that produces an electrical waveform with a certain frequency is called an oscillator. Oscillator is synthesizer are in charge of producing the fundamental sound source that may be adjusted and modified to generate a variety of tones and timbres. In a synthesizer, oscillator 1 is frequently referred to as main or basic oscillator. It often feature a number of adjustable characteristics, including the choice of waveform, sine, square, and triangle. Adjustment of frequency of pitch and modulation possibility. With the use of this setting, a musician or sound engineer may produce of a variety of sound, from straightforward to intricate waveform. Oscillator 1 of modular synthesizer is generally coupled with other modules such as filter, envelope, and amplifier. To process and shape the sound is produced. For music production or sound design reason, musicians can generate rich diverse sound by mixing numerous oscillators and adjusting their characteristics. It's better to keep in mind that the precise capability and feature of oscillator 1 might change based on the synthesizer or instrument in question, because various manufacturers may create their oscillator with distinctive property and extra functionality. So this is my circuit in multisim for oscillator 1. This is the output in the multisim, and I made a calculation. Negative feedback loop using the formula AV equal to 3, and I get the R1 equal to 10 kHz, RF equal 3 minus 1, 10 kHz equal to 20 kHz. I assume as 22 kHz. For the positive feedback loop, FR equal to 1 kHz equal to 1 over 2 pi RC, and I get the R equal to 159.15 kilo ohm. I assume as 158 kilo ohm. So this is my circuit in multisim. For RA 10 kilo ohm into the IC 741, for the RF 22 kilo ohm, and I set it 95%. In the bottom 1 nanofarad and 158 kilo ohm for the parallel, and the series is 158 kilo ohm and 1 nano ohm. Into the oscilloscope, when I run it, and I get the result 996 Hz, 28.2 volt for peak to peak, and the match voltage is 14.1 volt. And that's all from me. I pass for my group member, Muhammad Faiz. Thank you.
Thank you to Muhammad Naim Iskandar. Okay, my name is Muhammad Faiz bin Muhammad Nasir. My metric number is B0821100034 from class 2 BEE season 1/2. Okay, I would like to present about the oscillator 2. Okay, the given is type wing bridge oscillator, resonant frequency equal to 20 kilohertz, and DC supply is 15 volt. Okay, this is a circuit, and this is a calculation. Okay, for negative feedback loop, how to get the formula RF equal to 2 multiply RA. Okay, this is a equation. AV equal to 3, 3 equal to 1 plus RF per RA. RF per RA equal to 2 for oscillation. To comments, the value RF per RA should be greater than 2. Okay, the formula is RF equal to 2 multiply RA. Okay, we assume the value of RA equal to 14 kilo ohm. Okay, RF equal to 2 multiply 14 kilo ohm, we get the 28 kilo ohm, and we assume 30 kilo ohm. We put this value to multisim at RF. Okay, for feedback loop, positive feedback loop, FR equal to 1 per 2 pi multiply RC. Okay, we assume the value of the capacitor is 0.22 microfarad. And the formula is R equal to 1 per 2 pi F R multiply C, and inside the value have given, for example, resonant frequency 2 kilohertz and 20 kilohertz for RC FR, and for C is 0.22 microfarad, and we get the answer is 36.1 ohm, and we assume the value is 36 only. Okay, we go the multi-sim simulation. Okay, this is a circuit have done. Okay, RF equal to 30 kilo ohm, and capacitor is 0.22 microfarad. So we inside the value have done to multisim and run. Okay, this is output have done. Okay, the peak to peak value is 3.83 volt, and the frequency is 17.0 kilohertz. Okay, I think I have done present about the selector 2. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal B. Arifin. My metric number is B0821105542. So for my part, I want to present about low pass filter. So the specification is the cutoff frequency is at 8 kilohertz. So for the second order, I have to refer to the Butterworth response table. For my order is second order, so the pole is 2. For R1 per R2 is at 0.586. So after that, for the calculation, so RA per RB is 0.586. So I assume RA is 1 kilo. So I get the value of RB is 1.706 kilo ohms. Meanwhile, R1 is equal to R2 is equal to R, so I assume the value of R is 1.706 kilo. So after some calculation, I get the value of C is equal to 11.66 nanofarad. Therefore, C1 is equal to C2 is equal to C. So for the circuit, this is second order low pass filter circuit or the Salenki circuit. So this is the first pole and this is the second pole. So for the magnitude, both plotter, so I get the 8 kilohertz cutoff frequency. So the slope is negative 40 dB per decade. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Firdaus, and I will presenting for my part, which is rectifier. So the full bridge rectifier is an electrical circuit that transforms alternating current into direct current. The AC voltage from the main power supply is frequently converted into a DC voltage, suitable for powering electronic components in power supply and other devices. 4 diodes are stacked in a bridge arrangement to form the full bridge rectifier. The current can only go in one direction, which functions as one-way valve for it. 2 pairs of diodes in series are formed by connecting the diode to produce the 2 pairs. So this is the rectifier calculation. As we get here is VDC formula, which is 2 Vp over pi, and then the Vp out formula Vp in minus 1.4 volt, and then V ripple equal to IDC over 2FC. And this is the circuit for we measure the IDC, and then the circuit for rectifier circuit. From the rectifier circuit, as we can see, we use the Tetronic oscilloscope, and then we use the 20 voltage peak and the frequency is 30 Hz. Then the full bridge rectifier, which is 1B4 B42, and the capacitor value is 1 microfarad, and the resistor is 100 ohm. Then from the Tetronic oscilloscope, the graph as we get here is the voltage peak to peak is 20 volt for channel 1, and then the channel 2 voltage peak to peak is 18.1 volt. Then we measure the current for DC. You can see here, this is the IDC value, 59.217 milliamp. So back to the rectifier calculation, we use the value that we get from the circuit. For the VDC, the formula is 2 V peak. Our V peak is 20 volt over pi, and then we get here is 12.73 volt. And then the VP out formula is VP in minus 1.4 volt, which is 20 volt minus 1.4 volt. And then the V ripple formula, IDC over 2FC. So the value for IDC is 59.084 milliamp. And then the value of the V ripple is 0.985 millivolt. That is all. Thank you.
Hello and Assalamualaikum. My name is Diaudin bin Abdullah. My metric number is B08211036. I am going to explain about voltage regulator, which is the series shunt op-amp regulator. A voltage regulator is defined as an electronic device used in an electronic circuit to maintain a constant voltage at the output of any electronic circuit within the desired limits, irrespective of the variation in input voltage supplied and load current. It plays a vital role in transforming unregulated DC power supply to regular DC power supply with no significant variations in the output voltage generated. A voltage regulator is sometimes referred as a control element. Based on the arrangement of or placement of the control element, it can be either a shunt voltage regulator or a series voltage regulator. A shunt voltage regulator is always connected in parallel with the load in an electronic circuit. It is observed that the input voltage applied to the circuit splits into the shunt voltage regulator or the control element, and the rest of the current moves to the load. The shunt current plays a vital role in maintaining a constant and invariable output voltage at the output. A sampling circuit and comparator circuit are also present. The sampling circuit present in the electronic circuit generates a feedback signal to the comparator circuit, which in turn compares the applied input reference voltage and the feedback signal to produce a control signal as the difference. This control signal is basically the amount of current to be provided to the shunt voltage regulator element in order to maintain a constant voltage output at the load side. Here we can see that we use the op-amp and Zener diode to regulate the DC power supply. As you can see, the resistor is in parallel with the transistor. Here we can see that the output is 4.981 volt. The Zener voltage is 5.023 volt.
Assalamualaikum and hi to our lecturer, Encik Zulkarnain. Okay, today I would like to present my part in this assignment or project. my part is number 6, load. Uh, First of all, the question given load rated power equal PO equal 1 watt. Okay, this is my calculation. Given P load equal 1 watt, P load equal V load over up load, and this is the formula. And the answer is V load equal 5 volt, up load equal 5 square 2, and this and the answer is 25 ohm. Okay, next I show the output or simulation in I2. Okay, first of all, in paragraph 1, for parallel connection or voltage connection. Okay, first, this is DC power, 50 volt, and R1 Zener diode, transistor, and resistor 2. Okay, this simulation or result, I take one multimeter only, and this my result, and the value is 5.237 volt for voltage connection. Okay, next I explain the figure 2 for series connection or current connection. The circuit stays same, but I just adjust multimeter from parallel connection to series connection, and the value is 209.483 milliampere. Okay, next I explain about discussion. From the circuit that we designed, the oscillator produce a periodic electrical signal in sine wave to convert DC signal to AC signal. Voltage summing amplifier is used to combine the output signal from the oscillator. Then we use active low pass alter the frequency response of the filter circuit by producing more selective output response, making the output bandwidth of the filter narrower or even wider. After that, we use voltage rectifier to convert the alternating current AC to direct current DC, which is required to the DC operated system. Then output signal from went to basic shunt voltage regulator to provide regulation by shunting current wave from the load to regulate the output voltage. Okay, the last one I will explain about conclusion. We are able to effectively finish this job at its conclusion. We were also able to operate the circuit and accurate data. The number we receive are close to the figure we calculate. We trust patient that we are able to obtain the accurate data. The net issue that we encountered was releasing that we were having trouble putting the project circuit together. After discussion with our team about this, we are able to solve the issue and finish the job and produce accurate data. Okay, that's all from me. Thank you.